Good morning everyone. Today we are going to see OSUNIX lab, and in today's session we are going to see operating system program which is based on the SJF CPU scheduling algorithm, shortage job first. So this program you need to write in a C program to implement SJF CPU scheduling. There are two types of CPU scheduling, non-preemptive and preemptive scheduling. So preemptive scheduling programs become very lengthy. So we have written the program based on SJF non-preemptive scheduling. So in this program, the variables which are declared is, this variable is for process of array. This variable is for accepting the base numbers, burst time for the processes, and this variable WT variable is for calculating waiting time, and turnaround time variable is for calculating turnaround time, and remaining variables are for loops, and these variables are for calculating average waiting time and turnaround time. Then we have number of processes. You need to accept the number of processes, how many number of processes have come into the queue, and that will be stored in the n. And then we have the loop. Here inside a loop we are going to accept the burst time for the processes. So here I is equal to 0, that will be initialized in P, and then it will allow each processes to accept the burst time, and that will be stored in the variable bt of I. Then we have remaining two variables. This is the outer loop, this is the inner loop, and inside that we have taken one condition, and in this condition we are comparing the burst time of every processes with the next burst time. So in this we are comparing the burst time of every processes with the next processes. So whichever process has less burst time, that will be exchanged, and the process with the less burst time will be at the top, and the process with more burst time will be at the end, and this will be done in this exchange of coding this. And then once the processes with less burst time are top and the processes with more burst time are at the end. So once that is arranged, then you are going to calculate the average waiting time, that is waiting time total and turnaround time total, and for that you use the loops, and you are going to calculate here. This is the waiting time plus burst time, we will get the waiting time. Turnaround time plus burst time, we will get the turnaround time, and then you are going to calculate the average waiting time and average turnaround time. Then next we have the processes, burst time, and the waiting time heading you are going to display here. After calculation of waiting time, turnaround time, and average waiting time and average turnaround time, you are going to display those in a proper format on the screen, and this coding is used here. You can see here process will be displayed, then burst time will be displayed, waiting time will be displayed, and then turnaround time will be displayed, and then waiting average time and turnaround time average will be displayed on the screen. So this is the output how you are going to run this program. As this is a C program, so you need to use here the command to compile the program, gcc command with the program name .c. So always the C programming have the extension .c, and we call that as extensions is .c. And then you're going to run it using this command, and then you're going to accept the burst time for processes 0, 1, 2, 3, as there are 4 number of processes, and this will be stored 0, 1. This will be stored in the variable I. You can see this in the coding. We have used here the variable I, so that will be stored here. Enter the burst time for process 0, enter the burst time for process 1. So on, it will display on the screen. And then after calculation and all, this is the last steps. So final values it will display on the screen, and that we can see in this coding. So using this coding, the final values of all the variables will be displayed. And then we are calculating here Then the values of waiting time, average waiting time and average turnaround time will be displayed. So this program we are going to trace using this is a program for, this is an example of non-preemptive, and we are going to trace this. So 4 processes we have taken, and these are the burst time, and this is the average waiting time. So let us see if we trace it whether we get the same average waiting time and average turnaround time. Now for this coding, enter the process number and enter the burst time. For this coding we have here. So first of all, it is going to display on the screen, enter the processes. Then you are going to enter 4 and that will be stored in the variable n. Then you can see in the coding we have here loop. So this part is going to accept the burst time. So if the loop is there, using the loop we are going to accept the burst time. So first the value of variable I is 0. So value of variable I is 0 and 0 is less than 4. And once we enter the loop we have here I. See, I value is 0 and here also P of I is 0. So that will be initialized. Then you are going to enter the burst time here. And at BT of 0, that will be stored in BT of I. So at BT of 0 position, the burst time stored is 6. And then I value get incremented and it returns back to the loop. So this time I value is 1. 1 is less than 4. Then I value is 1 here. So it will be initialized. P of 1 is equal to 1. It will be initialized. And then it allows you to enter the next burst time process, and that will be stored in the location BT of 1. 8 will be stored. Then again the for loop will get incremented. This time the I value is 2. 2 is less than 4. Condition is true. Then so I value is 2. That will be initialized here. So it will be initialized and burst time will be entered here. So 7 you are entering here and that will be stored in BT of second position. Then again I will get incremented. So 3 is less than 4. Condition is true here. It will be initialized. Then it will allow you to enter the burst time for third position, that is fourth position. Then I value will get incremented. This time the I value is 4. 4 is less than 4. Condition is false here. So it comes out of the loop. So after this coding allows you to enter all the burst time of all the processes. Then it is going to come out of the loop and then it is going to execute this coding. This coding is to compare the burst time with the next processes. So this is the outer loop and this is the inner loop. So in the outer loop we have here I value. So I value is 0 here, and in the K loop we have here I plus 1, K is less than N. So let us trace this. So you can see here I value is 0, outer loop, 0 is less than 4. So then it enters into the inner loop. Inner loop is K. So I value is 0, 0 plus 1 is 1, and then 1 is less than 4. Condition is true. So we are using here comparing C condition. BT of I is 0. See, BT of I is 0 and BT of K we have here 1. You can see here BT of K we have here 1. So which value is stored in BT of 0? 6, and which value is stored in BT of 1? 8. So these burst times are stored. Now 6 is greater than 8. See, condition is false. Condition is false. So it will not execute this. As the condition is false, it will not execute this. It will go back again to the K loop. So it is going to go back again to the K loop by incrementing the K value. Now it is going to increment the K value. So this time the I value is 1. So 1 plus 1 is 2. So 2 is less than 4. Condition is true. So again it is going to check for the condition. So the outer loop is not going to change. The outer loop I value is going to remain 0 only. Only the values of inner loop are going to change. Only the values of inner loop, that is K loop values, are going to change. So earlier it was 1, now it is 2. So 6 will be compared with the next burst time process. As the condition is false, again it returns back to the K loop by incrementing. Now it goes to the K loop. This time the I value is 2. So 2 plus 1 is 3. 3 is less than 4. So again the first burst time will be compared with now next burst time. So this time the burst time is 3, and see the condition is true. 6 is greater than 3, condition is true. Now it will execute that exchange code. See, BT of 0 will go into this temp, that is 6, and BT of 3, which value is stored in the BT of 3? It is 3, and that will be now exchanged with BT of 0. So when this exchange of code is executed, the final value which we get is, see, at BT of 0th position 3 will be stored now. Earlier it was 6. Now we have exchanged it. So at BT of 0th position, less burst time will go now 3, and at BT of 3th position 6 will come. It is exchanged now. And even the processes are exchanged. Here. This is the coding for exchange of processes. So at BT of 0, process 3 has gone, and at BT of 3, process 0 has come. Now K loop will again increment, and 4 is less than 4. Condition is false here. See, now K loop has become false. So it goes to the outer loop I now. So it comes out of the K loop and it goes to the outer loop. Now the outer loop, earlier it was 0. You can see here earlier it was 0. After incrementing, it is going to become 1 now. So condition is true. So again it enters into the K loop here. Now K loop I value is 1 here. 1 plus 1 is 2. 2 is less than 4. So in the first column, the first burst time was compared with all other burst time. Now here the second burst time will be compared with all other burst time of processes. See now, the BT of 0 burst time we are going to compare with BT of 2 process, that is 8. 8 is greater than 7. See, condition is true now. So it is going to exchange the burst time and it is going to exchange the processes. So burst time 1 will be exchanged with burst time 2 now here. See here, burst time 1, 7 will go there, and in burst time 2, 8 will go. And even the processes will be exchanged. In process 1, process 2 will go. In place of process 2, process 1 will go. Even this is exchange. Now again the K value will get incremented. So now the I value becomes here 2. So 3 is less than 4, condition is true. So BT of 1 will be compared with now next burst time, that is 3. So 7 is greater than 6, condition is true. Again that will be exchanged here now. So BT of 1 will be exchanged with 6 and BT of 3 will be exchanged with 7, and even the process numbers will be exchanged here. So these are the values I have written here, 7, 6, 2, how it has exchanged. And next K value is going to increment. So K value is going to become now 4. 4 is less than 4. Condition become false. Now again it goes to the outer loop I. Now outer loop I is going to increment, and now I value is going to become 2. So like this way now burst time second will be compared with 3 now here. So like this way it goes on repeating until the condition is false. So you can see here 3 is less than 4. So again it will execute it. So it goes on repeating until the condition is false. So you can see here 4 is less than 4. It has entered into the K loop, and now K loop is false here. As the K loop is false, it goes to the outer loop, and even the outer loop becomes false. It comes out of the both loop. So after coming out of the both loop, the final value which we get here is, see, this is how it has exchanged. In P of 0 we have got 3. In P of 1 we have got 0. In P of 2 it is 2. And P of 3 it is 1. These are the process number. And these are the burst number we have got exchange. In BT of 0th position we have got less burst time, and then next less burst time, less burst time, and at last we have got the process with more burst time. So how even the processes we have exchanged. So even these processes have exchanged based on the less burst time. Then we have here calculating the waiting time. We have initialized both these variables to 0 for calculating the waiting time and turnaround time. So this is the coding which is going to calculate. So for loop we have used. See, it is going to initialize both to the zeros, and then we have the loop here. So first time you can see here the I value is 1. So I is equal to 1, I is less than 4. Condition is true, so it is going to enter into the loop. So what we have here, I value is 0. I value is, we initialize it. See, I value we have here 1. So it is going to start with 1. So I value is 1. 1 minus 1, it is going to be 0, plus BT is also, see, BT value we also we have here I minus 1. So it will be 0 plus 3. So it is 0 plus 3. So after calculating 0 plus 3, so in waiting time first position 3 will be stored, and then it will goes back to again to the loop. Now this time the I value is going to become 2. So it is going to calculate. Yes, this was the first step. See, this was the first step which has calculated. Now this is the second step, turnaround time. So it is going to calculate turnaround time. See the values which are exchanged I have written here, and then next step 4 steps. So it is 4 step it is going to calculate. After that it is going to increment the I value, then it is going to go to the loop. See, after calculating all these 4 steps, it is going to go to the loop. Now this time the I value is going to become 2. Now the second position, waiting time and turnaround time will be calculated. So this time the I value is 2, 2 minus 1. So we will get here 3 plus 6, and that will be stored in waiting time 2. This is the turnaround time second position value, and this is the average waiting time and turnaround time average. Next we have again the I value will get increment, it goes back to the loop. This time the value for waiting time 3 will be calculated here. So we have here waiting time 3. Then we'll get here the values. Turnaround time value will get for third position, waiting time average for third position, and turnaround time for third position. Similarly, it goes back to the loop. Now condition is false, comes out of the loop, and then at last it is going to execute this step to display all the final values on the screen. So it will display first heading. So this heading it will first display, and then using the loop we are displaying all the values one by one. So it is going to start with the 0th position. So P of 0, whichever the process value is there, see P of 0 will display, then whichever the value is there at 0th position, that it will display, and then whichever the value is there at waiting time 0th position, it will display, and turnaround time 0th position, that value it will display. So it will display all these positions whatever we have calculated, and then it is going to go back to the loop. Now this time the I value will get incremented, and then it will print next row values. Then again I value will get incremented, then it will print next row. Then when the I value becomes false, it comes out of the loop. Once it comes out of the loop, it will print the average waiting time. See, average waiting time, whatever the final value was there, it will divide it by n, and this value will get printed on the screen. So this is how we have traced this SJF algorithm. So the working is same. So we have compared each burst time with the another process burst time. So the process with less burst time will be at the top, and the process with higher burst time will be at the end. And then we are going to calculate it using the various loops and formulas. This is the formula which we have calculated. Okay, and this is how we are trace. So similarly, you are also going to trace this program as well as other programs you are going to trace in this way. and will be checked in the lab about the tracing of the programs. So after explanation of the program, you need to trace it at your home and you need to show it during the labs session in the college. Thank you. Shh.